let's talk about one of the applications of electromagnetism, which is an electric motor. So an electric motor is something that turns electrical energy into mechanical energy. So the energy of like moving stuff. So it's going to change electrical energy into mechanical energy. And an electric motor is a very simple device in principle. All that you have to do is run a current through a loop of wire inside a magnetic field. That magnetic field will exert a force on the sides of the wire, which will cause the wire to spin. And what you've done now is you've made electricity cause something to spin. And then you can attach something to that spinning bit and do all sorts of stuff with it. So let's look at an illustration here. So what I've got here, you can see you've got a coil of wire in the middle, and you've got north and south poles on the sides, so they create a magnetic field that goes through the middle. Now, if you remember from previously, we talked about the force that's exerted on moving charges. Well, if the current is moving up right here, then what happens is to use our right-hand rule, we point our fingers up because we point our fingers along the velocity, and then we fold them towards the magnetic field. So this is opposite. I believe this will look opposite for you. So what would look correct for you would be pointing my fingers up and then folding them like this towards the magnetic field, and that points the force into the screen. So what you see is then we have this force back here into the page. On the other side, if I start my fingers pointed down and then I curl them towards the magnetic field, that will give a force that's pointed out of the screen. And so both sides of this wire, because of that looping shape, both sides of this wire feel opposite forces, but opposite forces that'll cause it to spin. And so then it will spin and we get spin out on this axle here. So that's all that's happening, is if you have a loop in a magnetic field, then the fact that the current's going up on one side and down on the other means that they'll feel opposite perpendicular forces, and that will make them spin. So using the right-hand rule, like I said, the left side of this coil is pushed into the page or into the screen, and the right side is pushed out of the page / the screen. And this causes the coil, this causes it to spin. I don't know why that didn't end up on the same line there. So that's what we have here. Now, there is a little bit of fanciness here we actually use something called brushes. And this, if you look down here, you'll notice that we've got these two brushes, which are things that aren't actually attached to the coil, but the wire will come and just rub against this. So they're conductive, so allow the current to flow. But there's a gap here, so what ends up happening is the left side then always stays attached to the up current, the current going up. The right side always attaches to the down current. So this allows the current to always flow in the same direction. In other words, it's always going up near the North Pole and down near the South Pole, because when they pass, when it goes to in between, in the middle here, they're not attached to anything, and they, the momentum carries them to continue spinning until this metal part touches the brush again. So the left side of the coil will always be going up, the right side will always be going down, and this also keeps the loop from tangling. right? If you imagine if there wasn't, then the wire would wrap up, and then get tied. What would actually be the main problem is it would spin and then get pushed back because now you have the up on the right instead of on the left. That's again something that you may need some clarification in class, so feel free to ask if you have questions on it. But that's the basic of how an electric motor works.